Okay, for this problem we have 3x squared minus 10x minus 8. So let's see, we're trying to think of what are the two factors of 3, which is 1 times 3. For 8, it could be 1 times 8. I'm going to try 2 times 4 first. Okay, let's see. We need some combination of products that's going to add up to negative 10. And if I had a negative 12 and a positive 2, that adds up to negative 10. So that's the combination of products that I want. Now, these numbers go in the front of our parentheses because those are the factors of the first term. So I'm going to take 3x times 1x, and I can just write that as x. Okay, and now these numbers are the products of our last term, so they go at the back of the parentheses. Now I needed 3 to multiply times 4, but it really needs to be a negative 4 because I need that 12 to be negative in order to add up to a negative 10. Okay, the 3 multiplies times the first term. That's how I get my 3x squared. And then the only other thing it multiplies times in the second parentheses here is this last term. So since I want 3 to multiply times negative 4, I'm going to put my negative 4 in that outer position. Okay, and now I needed 1 to multiply times 2. This is like a 1x in the front here, that 1, and so that needs to multiply times a positive 2. Okay, now when we check these, so this right here would be my answer, and then I can check it by distributing. So I can check by taking 3x times x, so that'd be 3x squared, and then 3x times negative 4 would be negative 12x. 2 times x would be a positive 2x, and 2 times negative 4 is negative 8. And notice that these middle terms add up to a negative 10x. All right, next one we're going to do is x squared minus 9. So this, notice there's only 2 terms, and this is kind of like if we had x squared plus 0x minus 9. So the middle terms add up to 0. So because this is a minus, we need a 3 times a negative 3. Here it's just 1 times 1. So this would factor as x plus 3 times x minus 3. And then when you check it, you've got x squared and then minus 3x plus 3x and then minus 9. These middle terms, because the signs are different, they just add up to 0. And so we would end up with x squared minus 9. So this is a special case. This is the difference of perfect squares. And it factors as the square root of the first term goes in the front, and the square root of the last term goes in the back. And then because this is a difference, because there's a minus there, the signs need to be different. All right, so special formula there. If you have a squared minus b squared, that factors as a plus b times a minus b. Okay, so that's the difference of perfect squares. Now notice if this was a sum of if this was x squared plus 9, that would actually be prime. It doesn't factor because to get a 9 you would have to have the same signs. It could either be x plus 3 times x plus 3 or x minus 3 times x minus 3. And then when you distributed this out, you'd get x squared plus 3x and then plus another 3x. So those middle terms, instead of canceling, because the signs are the same, which they have to be if this is addition, what you end up getting is double in the middle in there, okay? And then this would be similar. You'd get x squared minus 3x minus another 3x, so it'd be minus 6x, and then plus 9. So the formula for a squared plus 2ab plus b squared is what you get if you've got a plus b quantity squared. The middle terms don't cancel out, they actually add up. You've got the same sign, so they're doubling up in there. Okay, so this, if this is addition, it doesn't factor. Okay, so it only factors if it's subtraction in there, difference of perfect squares. Okay, let's try this next one. All right, so the first thing I'm going to do, I notice both of these are divisible by 3, so I can factor out a 3. And also they are divisible by x, so I can factor out a 3x from both. So I'm going to factor that out, and I've got 3x times x squared minus 4. And then I've got this x squared minus 4, that's a difference of perfect squares, so that's going to factor as x plus 2 times x minus 2. And that is done. For this next problem, I've got a binomial, so 1, 2 terms, and I'm looking at a cubic term there. So I need to use my formula for the sum of cubes. And that formula is a plus b times a squared minus ab plus b squared. And this is a really important thing to have in your notes. There's also the formula for the difference of cubes, which is a minus b times a squared plus ab plus b squared. And these are just formulas, and we just need to know them and be able to apply them. Okay, I'm going to choose this first one because of the addition sign here. Okay, so I need to use the one that has addition. And so in this case, the a in this case would be x, because it's saying something cubed, and in this case it's x cubed. So every time I see an a in my formula, I'll just write that as an x. And then the second thing, what's cubed here is 2y, because 2y cubed is 2 cubed is 8 and y cubed is y cubed. Okay, so we're looking at each of these terms and trying to figure out, well, what is being cubed here. Okay, so that's the first thing, is to figure out what our a and our b are, and then I'm going to just simply go through step by step and copy this formula down. A plus b, I'm just rewriting this so I can actually use it, ab, and then plus b squared. Okay, I've decided that a is x and b is 2y. Okay, so every time I see an a, I'm going to just replace it with x. Okay, so this is an x in my formula, but an a in my formula, I need to replace it with a and x. And this b, I'm replacing with 2y. Okay, this a is replaced with x, and then I need to copy down the squared. Then I need to copy that minus. Okay, then I need to put in what what my expression is for a, which is x, and then my expression for b, which is 2y. And then it's always plus b quantity squared. And then we just clean this up a little bit if we can. In this case, I can simplify x times 2y, and I can rewrite that with the 2 coming first, and then times xy. And then here I can square both things. So 2 squared is 4, and then that would be times y squared. Okay, so I don't have to do much deep thought here. I'm simply using one of those two formulas, and I choose them based on if it's addition or subtraction. Okay. Okay, on this problem, I see that I have two terms, 1, 2. But I'm not seeing any cubes, okay? That's a fourth, and so it's not going to be the difference or sum of cube formula. So instead, let's see what we've got. First of all, I notice both these numbers are even, and so I'm going to factor out a common factor of 2. 32 divided by 2 is 16. 2 divided by 2 is 1. Okay, so notice that would be the opposite of distributing there. Okay, so I'm going to pull out my 2. And now, if I rewrite this, if I had a problem 4x squared plus 1 times 4x squared minus 1. All right, now this is also a difference of perfect squares. So I need to keep going. Oops. That 4x squared plus 1, that's prime because of the addition. So that one can't factor, but here because of the subtraction, that can factor as 2x plus 1 times 2x minus 1. And that is done. Okay, so let me just show you how I would check this. And I would actually start with this section right in here, factor that, copy everything else down. Okay, so that would be 2x times 2x would be 4x squared minus 2x plus 2x and then minus 1. So these terms would cancel out. Let's see, so that would be 4x squared minus 1. And then I'm going to multiply these. 4x squared times 4x squared would be 16. Let's see, 4x squared times 4x squared. We multiply the numbers, and then we have x squared times x squared. Add those exponents, and that would be 16x to the fourth. And then I would have minus 4x squared plus 4x squared, and then minus 1. Oh, don't forget the 2. And then these would cancel out. Those that just add up to 0. And then distribute our 2. So we would get 32x to the fourth minus 2. And since that is the same as what was originally given to us, we know that it checks out and we factored that correctly.